In this video we're introducing the for loop and we're replacing our while loop in the previous program with that. Now this program does exactly the same as the one in the previous program, so if I, didn't mean to do that, I meant to do that, and if I compile this program, hopefully I haven't broken it, nope. Run it, you can see that it does the same as before. It counts for 5 years and we've got the same amount of money at the end there. Okay, so it does the identical thing, it just does it using this for loop instead. Now everything you can do with a while loop in Java you can do with a for loop, and everything you can do with a for loop you can do with a while loop. That's not true of every programming language which has for and while loops. Some of them have some differences which mean you can't do everything with one that you can do with the other, but in Java you can. So the choice is really just a matter of style, and the standard choice, the standard decision you use, am I going to use a for loop or a while loop, is when I get to this point in the program, do I know how many times this loop is going to go round? And in this case I do. I know it's going to go round 5 times. We're going to start with year 0, we're going to finish as soon as years is equal to 5, because we'll carry on as long as years is less than 5. So as soon as it reaches 5 we'll stop, and every time round we're going to add 1 to it. Okay, so in this case we would use a for loop. If we didn't know at this point, so for example in the previous program where we were asking how many years does it take to reach a certain amount of money, then we use a while loop. That's the general rule. Now there are some exceptions to that, and we will occasionally break that later on in the module, but for now stick to that, and in fact if you always stick to that you won't really go far wrong in style terms. Okay, so the body of this loop is very similar to the last one. These 3 lines are identical. In fact, we're working out the balance. We've got the same mistake with the adding the new value there, balance plus equals interest. So we're working out the interest here and we're adding it to the balance here, and we're printing out the years and the balance there to essentially do a bit of debugging. But one thing that we did have before is we had this int years equals 0, this while, and this years plus plus, and effectively they've all been gathered together in the same place here. The way a for loop works is that there's 3 parts in the brackets and they're separated by semicolons, one there and one there. The first part says what do you do before you start the loop, and in this case we're going to say, well, we're going to create ourselves a variable called years. It's an int and it's going to start off with the value 0. The middle part is what's the loop condition. Under what circumstances does this loop keep going round? And it keeps going round as long as years is less than 5. And every time round the loop, at the end of the loop, immediately before this closing curly bracket here, we do the last part, which is that we add 1 to years. So pretty obvious by now, you could actually rewrite this if you wanted to by simply moving these parts. If I commented the loop out, I could say, well, if I could take this part here, Control C, and I can put it in there. I could take this part out here, Control C, and put it in a while here. Don't want that one. And I could take out this years plus plus, and I said put it at the end, but the last line here is in fact the debugging code, and we want that to be executed after we've done all of the logic, so I'm going to put it in there. Okay, so if I haven't made any mistakes, I should be able to compile this and it should do exactly the same as the previous one was. So they're completely interchangeable, okay? But because we know how many times this is going to go around before we start, generally we'll do it the other way around. Now similarly I could take this while loop here and I could turn it back into a for loop, and that means I could rewrite the double investment one as a for loop, and I'll show you how to do that in the next video just for completeness. But stylistically that would be bad because we don't know at the start of that how many times that loop should go around. I'm just going to fix this and put it back to how it was, and I'm going to leave that line there for just a minute. Now there is one slight difference between the 2 styles of loop. I've left this line in here, I'll comment it out for now. If you go back to the previous one, here we're declaring the integer years outside the body of the loop. Now that means that we could, if we wanted to, use it. So one thing I could do here is I could change this to be, and just say after years where, but now rather than being a fixed value in there, it would use the value from the loop here. I'm going to save that, and if I you can see it prints the same thing down here, but I could of course change that if I wanted to 10. Just going to clear the screen, recompile it and run it, and as you can see, it automatically runs for the extra number of years and it prints the right value there, so that's arguably better. Now if we do that here, I think, oh okay, all I need to do of course is cut and paste this line just to make life simple for myself rather than typing it in again. Don't type things if you don't need to. That looks okay. If I save this and I compile it, now it doesn't compile. It says cannot find symbol years, and the reason is that years is declared here. Now I said that variables, when they're declared, are only visible inside the curly brackets that surround them. This is kind of an exception in a for loop. You get a like special case, if you like, that if you declare a variable here in a for loop, it effectively means it's declared inside here. Okay, it's only visible inside this loop. You can use it for the loop counter there, you can use it inside the loop, but you cannot use it outside. So strictly speaking, this loop isn't exactly the same as the previous one, but you don't have to declare this variable here. If you really wanted to, we could take that out, and then we could actually declare it outside, okay? Because all this piece of code says is this is what you do at the very start of the loop. And if we've already declared a variable called int years, that's fine, okay? And now if I save it and compile it, this is number 2. Now it does compile, and it will in fact run, although I'm not going to run it. Now, one other thing to note is that you don't actually always have to put something in here. You can actually leave parts of these blank. One thing I could do, I could say, well, I've already declared int years there. Can't I just set it to be 0 at that point? If I need to use it outside this loop, okay, and I've already declared it outside this loop, can I initialize it then? What do I need this for? And the answer is nothing. I can actually take that out, and it will still compile. Having said that, this is starting to get a bit unnecessarily clever, and I would try and avoid that. If you find yourself having to do funny things like this, putting like variables outside and leaving bits blank, then probably you're overdoing the complicatedness of your program. You should probably try and stop and rethink and simplify your ideas a bit.